Greetings learners, this is your Sir Bren and I'm here to present the duality of linear programming problems. By definition, duality in linear programming states that every linear programming problem has another linear programming problem related to it and thus can be derived from it. Duality theory states the relationship between the primal and its dual, both on a mathematical and economic level. These are the important points or the steps. The original linear programming problem or LPP is called the primal, while the derived LPP is called the dual. First, check the sign or the signs of the primal's constraint or constraints if it matches with its objective. If it is maximization, the sign in the constraints are less than or equal, while if it is in minimization, the sign is greater than or equal. If signs or sign doesn't match, revise the primal's constraint. The number of constraints in primal is the number of variables in dual, while the number of variables in primal will be the number of constraints in the dual. And lastly, if constraint in primal has an equality sign, it will then have an unrestricted variable sign in its dual. So let us see this case of Windsor Glass Company. This is the mathematical model of the case, which is the primal is maximization, and by doing the steps we will convert this into a dual, which is a minimization problem. So let's start. So we have the problem. I have written in our whiteboard, max z is equals to 3x1 plus 5x2 subject to the following constraints. We have three constraints, namely x sub 1 is less than or equal to 4, 2x2 less than or equal to 12, and 3x1 plus 2x2 is less than or equal to 18, subject to non-negative variables, which is x sub 1 greater than or equal to 0 and x sub 2 greater than or equal to 0. Our first step is to check the signs of the primal constraints if it matches with its objective. So our first step is to check the sign in the constraints if it matches the objective. So we say maximization problem, it should be less than or equal. So far they are all less than or equal signs. Next, if signs doesn't match, revise primal constraint. So the sign matches, so we do not use this step. Next is the number of constraints in primal is the number of variables in dual, while the number of variables in primal will be the number of constraints in dual. So let's start solving. First, change it to minimization. Maximization becomes minimization, and then z or z asterisk. So it is called z asterisk or z star is equals to, it says here that there are three constraints, 1, 2, 3. It should have in the dual three variables. We will use since there are three variables, we use y sub 1, y sub 2, and y sub 3. By using the right hand side of the primal, it is equal to 4y1 plus 12y2 positive 18y3. So we have developed the dual objective function. Now we will go to the constraints. It says in our step that if there are two variables, we have two variables, x sub 1 and x sub 2 in primal. Therefore, there should be two constraints in the dual. In here, we have y sub 1 we have 1 y sub 1 y1, and then we have no x sub 1 here. Here in our third constraint of the primal, we have coefficient 3, so we have plus 3, and we skip the y sub 2, therefore this is y sub 3. And the sign, since this is minimization, the sign should be greater than or equal. In the right hand side is the coefficient of the primal, first coefficient of the objective function, that is 3. Here we have no y1. In the second constraint of the primal, we have coefficient 2, so this becomes 2 y2. We have no y1, we have y2, 2y2 plus, in the third constraint of the primal, we have positive 2 and y3 greater than or equal to 5. Lastly, and there are three variables. We have y1, y2, and y3 should be greater than or equal to 0. So we have now created our dual. We will check this to RPO-MQM. If we have the same dual output, it is the same problem. We will seek the output here, just maximize it. This is the primal, and in this section we will see the dual problem of the primal. So in our problem, we have minimize z star 4y1 plus 12y2 plus 18y3 subject to the constraint 1y1. We have no y2, we have 3y3 greater than or equal 3, and second constraint, we have no y1, we have 2y2 plus 2y3 greater than or equal to 5, and the three variables y1, y2, and y3 are restricted. Thank you very much, and hope you have learned from my lesson. Please don't forget to subscribe and I will see you on the next video.